Hey guys, it's Mrs. Marquette. Today we're going to be talking about adding and subtracting rational expressions. So we've already talked about some simplifying of rational expressions. We have done a lot of factoring and looked at fractions. So when we add and subtract rational expressions, we also have to think about fractions. I want to start off by just reminding ourselves, how do we add two fractions together? So if I look at number 1, 3/5 plus 1/5, if you remember back to adding and subtracting fractions back in middle school, our denominators were the most important piece of adding and subtracting fractions. So here we have a least common denominator. It's 5. So I can keep my denominator and add the numerators. 3 plus 1 is 4. Okay. If I don't have a common denominator right away, I want to see what could my common denominator be. And it looks like my common denominator could be 4. So what I want to do is I want to multiply both denominators by whatever will make our denominator common. So in order to get my 2 to be a 4, I multiply by 2 on the bottom, 2 on the top. Really, to get the bottom, or the first fraction to have a denominator 4, I have to multiply by 1. But multiplying by 1 doesn't really change anything. So this becomes 3/4 plus 2/4. Keep the denominator, add the numerators. So my final answer is 5/4. Subtraction is the same kind of thing. I've got to have a common denominator. Here I don't have a common denominator, so I look to find that my common denominator is 6. So I've got to multiply the denominator and the numerator of the first fraction by 2 to get the denominator to be 6. And then I multiply the denominator and the numerator of the second fraction by 3 to get that one to be 6. So this subtraction problem becomes 4/6 minus 3/6. Keep the denominators, add the numerators. 4 minus 3 is 1. This last one, we're not going to deal with as much today, but remember that fractions are just division problems. So if I have 1/2 and then big fraction bar 3/4, that's really like divided by 3/4. And how do we divide by a fraction? We multiply by the reciprocal. So I keep the first, multiply by the reciprocal of the second, and I don't need a common denominator for a multiplication problem. So that's the big thing here, is I can just multiply across the top and multiply across the bottom, and I can simplify to 2/3. So really the first 3 is what we're going to be looking at today, looking at adding and subtracting fractions. To add or subtract two rational expressions with like denominators, we add or subtract their numerators and place the result over the common denominator. So just like regular fractions. Looking at number 1, that means 4/3x plus 5/3x. We already have a common denominator. I'll call it least common denominator is 3x. So I keep the denominator and I add the numerators. 4 plus 5 is 9. Those are common terms, 4 plus 5. They're like terms, so I can add them up. Number 2 is super similar. Here I have an LCD of x plus 3. So it's important to not add those denominators up, even or subtract them. So I keep the denominator of x plus 3, and I subtract the numerators. Here it's 2x minus 4. Okay, the reason that I'm going to write it like this is because the reason I write it like this is because I don't have like terms. So I look at 2x and 4, and they don't combine, so I can leave it like that. I can also think about the fact that I have a GCF in that numerator. So I can say 2x minus 2 over x plus 3. Either one of these answers would be fine for this one because the x minus 2 and x plus 3 aren't common factors, so they don't divide out, they don't cancel. But you want to check that just to make sure that you don't have any like terms or like factors. So now we get to the more tricky stuff. To add or subtract rational expressions with unlike denominators, meaning I don't have an LCD, we find the LCD, and then we rewrite each expression as an equivalent rational expression using the LCD and proceed. So if I look at number 3, notice I don't have an LCD. X plus 1, I don't have an LCD. X minus 3. So what I really need is I need for there to be an x plus 1 and an x minus 3 in my denominators. So I can say that my LCD is going to be x plus 1, because I need to have an x plus 1, and an x minus 3. Okay, so now I look at my two fractions. What the first one is missing is x plus or x minus 3. So I can multiply by x minus 3 on the bottom, which means I need to multiply it on the top as well. And what the second one is missing is x plus 1. So I multiply by x plus 1 on the bottom, multiply by x plus 1 on the top. And now I can rewrite. Okay, I do 5x minus 3 over x plus 1, x minus 3, and then 7x plus 1. And we can write the denominator in the same order if we want, so it makes it really obvious to us, x plus 1 and then x minus 3. And now we do have common denominators. Notice these are exactly the same. So when you have a common denominator, you can keep the denominator, x plus 1, over or times x minus 3, and then combine the numerators. I might distribute my 5x minus 15 plus 7x plus 7, because now what I can do is I can combine the like terms. So notice I've got 5x and 7x. So the denominator stays the same. I've got x plus 1, x minus 3, but the numerator becomes 12x. And then negative 15 and positive 7 is negative 8. Okay. If I want, I can think about factoring out a 4. I get 3x minus 2 over x plus 1, x minus 3. Again, I would take either of these answers because nothing cancels, but this is the most simplified answer because I can see all of the factors and make sure that nothing has been left undone. So that's the big thing that you want to do with LCDs. Find your LCD first. So this is like step 1, finding the LCD. Step 2 is rewriting your fractions, and then 3 is combining all of your like terms. So take a look at number 4. I definitely don't have an LCD because my denominators are x squared and x minus 1. So what I really want is I want both of those terms to be in the common denominator. Okay, so I'm going to write parentheses around each part because I can't just like tack on a squared here. Because remember that parentheses are kind of like force fields. They mean that that is one term in and of itself. So what the first one is missing is the entire thing x minus 1. So I got to multiply the top and the bottom by x minus 1. Second one, what it's missing is x squared and x squared. Okay, so when I rewrite, I'll get 3x minus 1 over x squared, x minus 1, minus x plus 1 times x squared over x squared, x minus 1. Okay, notice now the LCD is x squared times x minus 1. And we can simplify. So this was step 1, finding the LCD. Step 2 is rewriting. And then step 3 is combining. So I get 3x minus 1, x squared, x minus 1, minus x to the third plus x squared over x squared, x minus 1. Okay, notice that's because I distributed the x squared into both pieces of the parentheses. Right? Now, simplify. I keep the denominator, x squared, x minus 1, and then combine your numerators. You get 3x minus 1. Don't forget to distribute that negative. So I get negative x to the third minus x squared. Okay, try to combine any like terms that you can. It doesn't look like we can here, so I will just list these in order. I'll get negative x to the third minus x squared plus 3x minus 1 over x squared, x minus 1. In some books you'll see they'll take out a negative in the numerator, they'll factor it out, but I'm okay if you leave it like this. Once you have it so that you can't combine any like terms and you can't cancel out any factors, then you're good. Number 5, here you're going to be tempted to start canceling because you have an x in the numerator and an x squared in the denominator, but be careful because there's a plus. We can't mix that right now. What we can do is we can find an LCD. My LCD here, I have an x squared and I also have a 2, right? So what's missing in the first is a 2 on the bottom and a 2 on the top. What's missing in the second is an x squared on the bottom and an x squared on the top. So I multiply, I get 10 over 2x squared, and I get x to the third over 2x squared. Okay, keep the denominator, and then add your numerators. 10 plus x cubed, that is not 10x cubed. Those are not like terms. So I'll even list the x cubed first. X cubed plus 10. We could think, is this like a sum of cubes? Because I've got the x cubed. So if I wanted to factor, I get x, x, and x. But the 10, that isn't a perfect cube. So we'll just leave it as x cubed plus 10 over 2x cubed. Okay, this last one is maybe the trickiest. I've got 3x cubed as my first denominator and 6x to the fourth plus 3x cubed as my second denominator. I think you're going to be tempted to just like add 6x to the fourth to the bottom and add 6x to the fourth to the top, but we can't do that with adding. We can only include things on the top and the bottom by multiplying, right? So what we want to do actually is factor this and see, are there like terms in the first or in the second and first denominators. So my GCF is 3x cubed, and then what's left is 2x plus 1. Okay, now notice that this 3x cubed is in both denominators, so that's common. Really all that's missing from the first denominator is a 2x plus 1. So I'll multiply 2x plus 1 and 2x plus 1, numerator and denominator. So what I'm left with is 4 times 2x plus 1 over 3x cubed, 2x plus 1, plus x over 3x cubed, 2x plus 1. I've got a common denominator, so I can go ahead and simplify. I get 8x plus 4, and then plus x over 3x cubed, 2x plus 1. Notice I could do that because I distributed and then I added my two numerators together. Simplifying, keep the denominator the same as it was in the last one, but then x and x, or x and 8x are like terms, so I get 9x plus 4. And that is my final answer. Notice numerator, I can't even factor out a GCF, so that is definitely just the end of the problem. Okay, so that's kind of problems that the LCD is a little easier to find. Number 6 is the first time we start factoring. All of the ones on the second page we're going to have to factor and then keep going. So number 7, it's hard to see what our common denominator is right now. So what we're going to do is we're going to factor. I get x plus 2 as my denominator for the first. And then I get x plus 2, x minus 2 for the denominator on the second. Now, for my LCD, I really have to figure out what am I missing in the first denominator, what am I missing in the second denominator. So I usually write down the first denominator just as it is, x plus 2, x plus 2. And then I look at the second denominator and I see, like, am I missing anything from that second denominator? So x plus 2 is already there. I've got it. So I don't have to rewrite that down. Don't double count it. And then x minus 2, that I don't have yet. So I'm going to have x minus 2 as well. Okay, so this is my LCD. Now, what am I missing in the first denominator is just x minus 2. So write x minus 2. Okay, in the second denominator, I am missing another x plus 2 because there's 2x plus 2's and 1x minus 2. So now I can start simplifying. This is big step 1. Step 2, I'm going to have x plus 2 times x plus 2, or x plus 2 squared, x minus 2. And then I can FOIL. So x squared plus 1x minus 2x minus 2. And then we'll subtract 2x plus 4. Okay, so we've distributed. And then on this denominator is exactly the same. So we'll keep our denominator. And now we have to simplify. Okay, so if I distribute my 2x and 4, I get negative 2x and a minus 4. Okay, combine your like terms. I definitely have 1x squared, and then I've got 1x, negative 2x, and negative 2x. So 1x minus 2x is negative 1x minus 2x is negative 3x. And then minus 6 over x plus 2 squared x minus 2. Okay, we can think like maybe we can factor the numerator. So things that multiply to 6 are 6 and 1, 2 and 3. I don't think there's any way for those to add up to negative 3. So we can leave it with this as my final answer, x squared minus 3x minus 6. Number 8, we've got to do some more factoring because we've got complicated denominators. That's really your hint, is there's too much going on. I can't really tell what the LCD is. So I will go x plus 3 to factor. Again, if you're having trouble factoring, seeing that right away, go back and watch some of those factoring videos from the factor chapter. The second denominator is a difference of squares. So I get x plus 3 and x minus 3. Okay, take your LCD. Again, I usually say that the LCD starts with the first denominator, so x plus 3 times itself. And then for the second one, I check, have I already covered all of my factors? So x plus 3 is already covered. X minus 3 is not, so I have to include that in my LCD as well. Okay, so then I look back. This is my LCD. I've got to include everything from the LCD in both fractions. So I have x plus 3, I'm missing x minus 3. So I multiply top and bottom by x minus 3. The second one, I am missing another x plus 3 because my LCD has 2 of them. And don't forget when you are simplifying that you've got a minus in the middle. Okay, so now go ahead and simplify the numerators. X minus 3, x plus 1. We can multiply x times x times 1 is positive x, negative 3 times x is negative 3x, negative 3 times negative 1 is negative 3. And then we've got a negative 1 times x plus 3. Okay, distribute that and you'll get negative x minus 3. And then on the bottom, I have x plus 3. I've got 2 of those, so I'm going to put x plus 3 squared, and then x minus 3. The last thing that we can do is simplify everything in your numerator. So we have x squared. There's only one of those. But then we've got 1x minus 3x minus another x. That is negative 3x. And then negative 3 is negative 6 over x plus 3 squared, x minus 3. Okay, again, I can't factor the numerator because of the same reason as the last time. We don't have any factors of 6 that add up to 3. Right, so I can leave it. Number 9, the last two, I think you guys should try these two on your own. The first one you'll notice already has an LCD. The number 10, you have to work on a little bit more. But you can pause the video. Otherwise, I'll start them right now. Number 9, again, we've got our LCD already, is x plus 1, so I don't really have to do step 1, or I don't have to do much work for step 1. Step 2, I need to say, keep the LCD, 2x, or x plus 1, and then I keep the numerator, 2x minus 1 minus x. That's step 2. Step 3 is combine like terms. So 2x minus x is 1x minus 1 over x plus 1. Now remember, you can't simplify those denominators because they are each a term. One is a plus, one is a minus. All right, so our final answer is x minus 1 over x plus 1. Number 10, I have to factor. There's a lot going on here. So I factor x plus 3, x plus 1. And then second denominator, I get x plus 3, x minus 3. Okay, that's a difference of squares. create your denominator. Start with your first denominator, x plus 3, x plus 1. And then in the second denominator, see what have you already covered. The x plus 3 is already covered. X minus 3 is not, so I will put x minus 3 as well. Okay, so what's missing from the first denominator is x minus 3. What's missing from the second denominator is x plus 1. And do all of your simplifying. So denominator is x plus 3, x minus 3, x plus 1. The numerators are 2x minus 6, and then plus x squared plus x. Notice you don't have to be careful about the signs because there's a plus in the middle. And then I can simplify. X squared, x plus 2x is 3x, minus 6, over x plus 3, x minus 3, and then x plus 1. And that is your final answer. Okay, this is going to take some practice. This adding section is sometimes the hardest section, so make sure that you are really doing all three steps, finding your LCD, combining your two numerators, and then simplifying everything that you can. Be really careful, write down all your steps and write down them in a very organized way, and I think you guys will be fine. Go ahead and try those practice problems, and I will talk to you later. Bye-bye.